Okay, we're going to do our doodle notes on covalent bonds. I need you to, each screen is going to be a different section of the front of the page. And so, if you look, we have on the, okay, at the top, I want you to label it for 2 covalent bonds. And then in the top third, we're going to talk about how covalent bonds are named. In the middle, we're going to talk about covalent bonds. And on the bottom third, we're going to talk about the characteristics. Okay? So those are if you're on the front of the page, that's what we're going to try and to fit on the front of that page. So we're going to go into the name first. First thing we're going to do is we're going to break apart the term covalent. Remember, this is the top third of your page. I'm just going to take up this whole screen, though, so I can write big. So covalent, for covalent bond. The co means to share. So some examples of where we use the prefix co is cooperate, means to work together or to share the work. Co-ed is like a when 2 people will or a group. It's a co-ed means both genders, female, male within. A co-pilot. Like on a plane, the co-pilot's going to help fly the plane. He's going to share some of the work. So the prefix co means to share. The root word valent means valence electrons. Sorry. Okay, so covalent means the sharing of valence electrons. So a covalent bond is valence electrons that are being shared. Okay? And another thing to remember, that a synonym for a covalent molecule or a covalent compound is a molecular compound. So we're going to write that in a little box to the side. Okay, just a reminder that compounds made with covalent bonds are also called molecular compounds. Okay? So now we're going to go to covalent bond. So now we're moving to the center of the page. So what happens in a covalent bond is that electrons are going to be shared instead of transferred. So we're going to look at diatomic oxygen. And diatomic di means 2 and atomic means atoms. So we're talking basically about 2 atoms of oxygen. So that's what makes it diatomic. You could have diatomic nitrogen, diatomic carbon, whatever. So this is diatomic oxygen. So what happens is if you look at oxygen, we're going to make a dot diagram. It has 6 valence electrons. Okay. It wants the magic number 8, but it just doesn't have 8. Okay, it has 6. So it needs to borrow 2 from somebody. Well, let's say another oxygen comes nearby, and that oxygen has 6 valence electrons. So this oxygen is going to share 2 of its electrons with this oxygen, and this oxygen is going to share 2 of its electrons with this oxygen. And so what you have is a bond between the 2 oxygens. So if you count it, you're going to see that this oxygen has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So it's happy. And this oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So we're going to write out what we just learned. And I'm going to type it just to make it a little bit faster, but you can handwrite it. Poof, just like that. So, just a reminder that the oxygen had 6 valence electrons. It just needed 2 more to get that magic number 8 valence electrons that it wants. To do this, it's going to borrow or share 2 electrons with another oxygen. And that's how covalent bonds form. It's the sharing of electrons, not the transferring of electrons. So now we're going to go to the bottom third of our page, and we're going to talk about the characteristics of covalent bonds. Okay, so let's talk about the characteristics. So covalent bonds are directly opposite of ionic bonds. Covalent bonds are weak bonds, where the ionic bonds were really strong because they transferred electrons. Covalents are weak. And because they're weak bonds, they have a very low melting point. And also because they're weak bonds, they don't allow electrons to pass through freely. And so they're very poor conductors of electricity. Which means they don't allow electricity to pass through them very easily. So now we're going to turn to the back of the page, and we're going to talk about the 2 different types of covalent bonds, the polar and the nonpolar, and where they come from. So once again, on the back of the page, we're going to divide our page into thirds. Imaginary lines. If you want to draw the dotted lines, that's fine. The top part, we're going to do polar. The next part, we're going to talk about nonpolar. Oops, not no polar, but non. And then the bottom part, we're going to talk about what makes covalent bonds. Okay, so we're going to go into the polar part first. Okay, a molecular compound is said to be polar when the electrons are shared unequally in the covalent bond. So we're going to write that down first. And I'm going to type it to make things go faster. Okay, so a polar molecule is when electrons are shared unequally in a covalent bond. An example is a water molecule. So let's look at a water molecule. So to make up water, you have to have 2 hydrogen and 1 oxygen. Now let's imagine that this is a game of tug of war. Okay, and here's the little flag on the tug of war. What's going to happen is that the oxygen is stronger. And so he's going to pull harder on the tug of war than the 2 little hydrogen. And so, because let's imagine that the flag is a negative charge, because that negative charge is getting pulled more to the oxygen side, then this side is going to have more of a negative charge, leaving the hydrogens to have more of a positive charge, because the negative valence electrons are going more towards the oxygen side. So if you look at the molecule, there's a bond because hydrogen is sharing a valence electrons with this oxygen, and this hydrogen is sharing a valence electron. Why does that happen? Well, if we look, this hydrogen has a valence only 1 electron. This hydrogen only has 1 electron. And oxygen has 1, 2, 1, 2, 3, 4, 5, 6. So if you see now, by sharing electrons with hydrogen, you will see that it has 1, 2, 3, 4, 5, 6, 7, 8. So now oxygen's happy, and the hydrogen gets to share all of these oxygens, so it's happy, and the same thing with this one. Now, because what's really happening is that the hydrogen the oxygen is pulling stronger on the hydrogen. The oxygen has an overall negative charge on this end. and the hydrogen have an overall positive charge on this end. And what happens because of this is that other water molecules are attracted because the positive hydrogen end of another water molecule is attracted to the negative oxygen end, and that keeps happening. This is what causes water to have surface tension. It causes water to be a great universal solvent because those opposites are attracting. And it also helps with capillary action, which is where water will go against gravity up the stem of a flower. So we're just going to make ourselves a little note. So what we have is just a reminder that hydrogen's valence electrons are being pulled closer to oxygen. So the valence electrons are being pulled closer to oxygen, making the oxygen side overall negative, leaving the hydrogen side to be overall positive. Okay, so in the middle of the page, we're going to talk about nonpolar. Now for nonpolar, it's the same thing, except we have a game of tug of war. Here's my valence electron flag. In this case, the two are equally pulling on the valence electrons. And so there's not a positive or a negative charge on each side because the valence electrons kind of stay in between equally, and they're equally shared. So a good example of this is what you're breathing out right now, which is carbon dioxide. Oxygen, again, has 6 valence electrons. I can count. And this oxygen has 6 valence electrons. In carbon, see if I can do some little dots here. No, won't let me do it. Okay, carbon has 4 valence electrons. So what you're going to see happen is that carbon is going to share 2 of its electrons with this oxygen, and oxygen is going to share 2 with carbon. And this side, carbon is going to share 2, and oxygen is going to share 2. So you actually have 2 double bonds on each side, and a double bond is written with 2 lines. If you were to do a triple bond, it would look like this, okay? In that case, you wouldn't have a triple bond there. You would probably have one with nitrogen. Okay, so you've got a double bond, and they're equally being pulled. So these are equally being shared with each other. So we're going to write a little note to remind us about nonpolar. So a molecule is nonpolar if the polar bonds cancel each other out and are equally shared. So that's a nonpolar. So what makes covalent bonds? This is going to be the bottom third of our page and the last part of our doodle notes. So if you were to look at the periodic table, and I were to give you two random elements and ask you if they were an ionic bond or if they formed a covalent bond, then what you would see is if right here's the zigzag line. We knew that ionic bonds were made when metals, okay, from this end combine with nonmetals and metals from this end. So that made ionic bonds. So if they're far apart from each other, that's an ionic bond. But if they're close together, like two nonmetals, like carbon and oxygen, or nitrogen and oxygen, then you're going to get a covalent bond. So this is usually formed when nonmetals combine with nonmetals. So you can see here, when nonmetals combine with nonmetals, so if they're close together on the periodic table, it's going to be a shared electron bond. So a shared valence electron bond. So think of it this way. If you're going to share a pie with somebody, they need to be close by. So if atoms or elements are going to share electrons, they need to be close to each other on the periodic table. If you want to share a pie with somebody in California, you have to transfer the entire pie or the entire piece, the entire electron, to California. You can't share it. You have to kind of give it to them. You have to send it to them. So if they're on far ends of the periodic table, it's going to make an ionic bond. I own it. It's mine. Ionic. If they're close together, it's going to be a covalent bond. And that's it for our doodle notes.